Nowadays, there are a lot of ways to power a car, and that's why we need to talk about the electric cars. Hi, my name is Axel Alejandro Pastrana Castañeda, and let's talk about the electric cars and how to optimize them. Once. Nowadays, all powers the majority of machines around the world, but this dependence comes with a high cost. Environmental impact. In order to address this challenge, we turned to a simpler, sustainable alternative to oil, and no, it's not hydrogen power. It's a galvanic cell built from copper and magnesium. In our cell, a piece of magnesium metal serves as an anode and a copper plate as a cathode. Both are immersed in a copper sulfate solution, and when they are connected, magnesium atoms start oxidizing, releasing the electrons and forming Mg2 ions. Simultaneously, C2 ions in the solution accept the electrons at the cathode, depositing as metallic copper. This continuous flow of electrons through an external surface generates an electric current, something that is clean energy directly from straightforward redox chemistry. To prepare our electrolyte, we calculate that dissolving 7.98 grams of copper sulfate pentahydrate, commonly known as blue vitriol, in 40 milliliters of water yields to a 1.25 molar solution, which is an optimal concentration for the ion exchange. And for found the theoretical values from the cell potential, we based on the standard electrode values, and the result of this equation is of 2.71 volts. Experimentally, our open circuit measurement was 3.05 volts on a digital multimeter. The reason of this variation are the real-world factors, such as the concentration deviations or the internal resistances that influences the performance. Finally, we integrated the cell into a mini car chassis, rating the electrodes to a low voltage DC motor. Once activated, the vehicle starts moving smoothly, demonstrating that a small galvanic cell can replace conventional batteries for low power applications. This experiment does more than a showcase to an alternative power source. It underscores the power of scientific thinking. By precisely delimiting the problem of fossil fuel dependence, strategically selecting an easily assembled galvanic cell, and comprehensively interpreting both theoretical and experimental data, we create a viable prototype. And for the future, this prototype can be scaled and refined, inspiring future innovations. And if we embrace rigorous analysis and creative application of fundamental principles, we can transform environmental challenges into opportunities of sustainable progress.